Alright, this is part 3 of the study guide. Let's get started. To find the area of this figure, we're going to go ahead and just break this into 2 parts real quick. Alright, we broke this figure into 2 shapes. We just multiplied 12 times 9 to find the area of this rectangle, which is 108. And then down here, if this piece is 12 from here to here, then I know that this piece is going to be 9 from here to here. I took 12 away from 21. And then this rectangle is going to be 9 times 13. And we get 117. Add them together, and we're going to get 225 square units. Okay. The area of the parallelogram. Area of the parallelogram is really easy. It's base times height. All I have to do is recognize that 8 is the actual height, so I do 12 times 8, and that's going to give me 96 square units. Find the area of a regular heptagon. Heptagon, if you didn't know, is a 7-sided figure. Okay. The apothem is approximately 5.58, and each side is 14. Well, the area of an apothem, a regular one, is 1/2 PA. Okay. The P stands for perimeter. To find that, it's going to be 7 sides times 14, which is the side length. That's going to give me the perimeter of 98. And then they already told me the apothem is 5.58 centimeters long. So I just plug this in. 1/2 of 98 times 5.58. Put that in the calculator. And we should come up with about 273.42 square centimeters. And we want to make sure that we put squared centimeters on there, because we are talking about area. Alright, flip it and rip it. Okay, 36. Find the area of the triangle below. Well, we just remember that the area of a triangle is 1/2 base times height. Okay, the base of this figure is going to be 25. The height right here is 14. Okay, and when we multiply those out, we're going to get 25 times 14 times 1/2. And we should get 175 square units. Again, I don't have any units given to me, so we just say square units. Okay. Find the area of a regular hexagon with a side length equal to 8. This is probably the longest or more time-intensive problems on our study guide. But here we have a beautiful hexagon, 6 sides, and we're going to draw a triangle in here. Now, if you remember, each of these central angles right here would be 360 divided by 6, which would be 60 degrees. So this is 60 degrees in here. But when I drop down the apothem, it cuts it in half to 30 degrees. So we've created a 30, 60, 90 triangle. The side length is 8, but when that apothem drops down, it cuts it in half as well. It's the 4 and 4. So if I were to take this little triangle and draw it larger, here's my apothem. Here is 30 degrees. This is 90. This would be 60 degrees, and this is 4. So 4 is in the x position, and A is in the x rad 3 position. So my apothem is going to be 4 rad 3. Once I know my apothem, I just need to know my perimeter, which is going to be 8, which is the side length, times 6 sides, which is going to give me 48. Now that I know both pieces of information, I can plug it into my formula of 1/2 perimeter times apothem. And the good news here is I'm going to leave this in terms of radicals, rad 3 to be precise. And we're going to get 96 rad 3 square centimeters as my final answer. Well, it's quite time intensive, but I think we did pretty good. Trapezoid. Area of a trapezoid is 1/2 height, B1 plus B2. And what we can do here is we plug in the height. We just got to recognize the height is the 10, not the 11. So we get 1/2 10 times 13 plus 15. Doesn't matter which one's base 1 or base 2 because you're adding it. Order doesn't matter. If you do that correctly, we should get 1,400 squared units. It's 812. Number 39 is a very similar question. We're just using the same formula, but we're going to work it backwards. Okay. We're going to find the height of the trapezoid, so I'm going to get everything but the height. So it says my bases are 10 and 18, so I'm going to do 10 plus 18 times height, I don't know, 1/2 equals, and it tells me the area is 126. So essentially I'm working this problem backwards. If I add 10 and 18 together, I get 28. Half of 28 is going to give me 14. So I get 14h equals 126. If I divide by 14, I'm going to get h equal to 9 centimeters. Okay? So again, that's just using the same formula, but we're using our algebra backwards, in a sense. All right. Find the area of a rhombus who has a perimeter of 40 and one diagonal that measures 8. Okay, so let's go ahead and draw out my rhombus. If you recall, rhombuses have 4 congruent sides, so if the perimeter is 40, I know all my sides are 10. And I'll draw my 2 diagonals. We also know that diagonals form 90-degree angles, all of them. And if one diagonal is 8, that means it gets cut in half into 4 and 4. I need to find my other diagonal. To find that, I can use Pythagoras Theorem as 4 squared plus x squared equals 10 squared. If I do this in my calculator, I'm going to get approximately x equaling 9.2. Okay, so if this is 9.2, this is going to be 9.2 as well. Okay? Again, it's just using Pythagoras Theorem. Now, the area of a rhombus is given to us by using the area formula, which is area equals 1/2 diagonal 1 times diagonal 2. Diagonal 1 is going to be 8. Diagonal 2 is 9.2 plus 9.2, which is going to be 18.4. And then we're going to just take 1/2 of that. No. And we should come up with about 73.6 square centimeters. Okay. Flip it over. Find the area of this rhombus is much easier because we already know the diagonals, so we literally are just going to say 1/2 of 10 times 14, which I believe is 1/2 of 140, which is 70 square units. So it's always pretty easy. Find the area of a circle whose diameter is 24. That means the radius would equal 7, which means the area is pi r squared, which means the answer is 49 pi. Psychedelic, I don't know why I thought that was 14, but we get, thank you, random class member named Caitlin. 12 squared is 144 pi, which is the actual correct answer, and that's also in squared units. Thank you for checking that. Again, half of 24 is 12, not 7. Sorry. Okay, I was doing so good, right? And then just completely utter failure. Okay. Slightly depressed now, but I'll make it through. Okay, here we go. 43, find the surface area and volume. So we need to know both formulas. Volume is easier, so we'll do that one first. Big B times H. The most important thing on this shape is you identify what your base figure is. It doesn't matter what you choose. I'm going to choose this piece. And as long as the base figure is parallel and congruent, we can use it as a base figure. So the area of the base is going to be 3 times 4. And the height of the prism is the distance between the two bases, which is going to be 9. So 3 times 4 times 9 is going to give me 108. So we get 108, and this is going to be centimeters oh, I'm sorry, I put that in the wrong volume. 108 centimeters cubic centimeters. So sorry, that's our volume. Volume first, not surface area. Okay. Surface area is equal to pH plus 2b. P stands for the perimeter of the base figure. That's going to be 3 plus 3 plus 4 plus 4. Okay, if we do that correctly, we get 817. Just kidding. We get the perimeter to be, what is that, 6 plus 8 is 14. Yeah. And then the height of the prism is still 9. Plus 2 times the area of the base, that was 3 times 4, which is 12. And we get 14 times 9, 126, plus 24, and that gives us 150 square centimeters. There we go. That's the correct answer. Okay. So again, surface area and volume, great things to have on a note card that you can have for the test. 3x5, double-sided. Moving on. Faux de faux, knocking at your dough. Okay, this one was kind of tricky, but this is a 90 degree right here. Now that we know that it's a 90 degree, this makes life a lot easier. We're going to go ahead and do the volume first. Big B times H. If you haven't realized, the area, or the base figure is the triangle. It's the only one that is a congruent figure and parallel. So the area of the base is going to be 1/2 8 times 15. Okay, and then we're going to multiply that by the height, which is 19. So this would be 60 times 19, which gives me the volume of 1,140 cubic inches. Okay? Surface area is a little bit trickier. Surface area, perimeter times height plus 2 times the base. But we already know the base is 60. That makes it easy. We know 19. The perimeter is the hard part. Do I know the perimeter of this figure? Well, I have 8 and 15, but I don't know this last side right here. Okay? But if I use Pythagoras Theorem, I can find it. And if I do this correctly, x equals 17. So I know that this final side is 17, so all I have to do is add 8 plus 15 plus 17 to give me my perimeter, which is 40. And if I multiply that and add it correctly, I should get a surface area of 880 square inches. Okay. Cool. These ones are taking longer, huh? We're not going to make it. Alright, this might be our last one, 45. We'll take a break. Alright, find the surface area and volume of the cylinder. Okay. So surface area and volume. Volume we'll start with first. Volume is pi r squared times height. My radius is going to be half of the diameter, so that's going to be pi r5 squared times the height. That's going to be 25 essentially times 14. It's going to give me 350 pi cubic units. Okay. And then my surface area is going to be 2 pi r times height plus 2 times the area of the base, which is pi r squared. And we're going to get 2 pi 5 times 14 plus 2 pi 5 squared. This is going to become 50 pi. Over here, this is going to become 140 pi. Oh, I can do this in my head, yes. And we get 190 pi square units. Okay. And there we go. That's our last one. Again, all these formulas, definitely make sure they're on your study, your little note card. Okay. All right, we're going to stop it there.